Okay, good evening. First of all, thank you very much, Antonio and Salvador, for the invitation to make this presentation. And also thank you very much for the great organization of this Learning Analytics Summer Institute local here in Madrid. So we are going to present Alaska, that is one of the works of the research works that we are doing at University Carlos III of Madrid. Is one of our research lines in learning analytics. And this tool is a tool that is an extension of the learning analytics features that are in the Khan Academy platform. So the Khan Academy platform is a MOOC platform in which students can watch videos, solve exercise, have different gamification elements. We will see deeper details later about this platform. And the Khan Academy platform was one of the platforms that were more advanced in the learning analytics area. It already includes many visualizations that help teachers and students to make decisions about the learning process. And we took as base this this platform, the Khan Academy platform, and what we did was to extend the functionality that was there in the Khan Academy platform. In addition, 2 years ago, our university, the University Carlos III of Madrid, started a project in which students that register in university for first time, for making their first courses, they were given some help with this platform, with the Khan Academy platform, but also with the Moodle platform, so that these students can improve their skills that are needed when they enter in the university for the first courses. So I'm going to show you the overview of what we are going to talk now, Jose and me. In this work, okay, I come back to the last slide, has been done mainly by Jose Ruiz Pérez, myself, and Carlos Delgado Clos, as is in this slide. But there are other different people that in our research lab that has contributed. And you can see in the next slides with the publications the list of the different authors that have contributed in different parts of this work. So I'm sorry that the presentation, the slides are in Spanish, but okay, but we will talk in English here. And okay, first we will give an introduction of Alaska, the context where we have already applied this tool with about in total 1,000 students, taking into account all the courses. And next we will go into a summary of the different things that we have done and the things that we are planning to do regarding this learning analytics extension for the Khan Academy platform. So we will cover about inference of information from low-level data, the architecture, technical details about the tool. We will cover also a demonstration of the tool, and Jose will give also a demonstration from the computer, and also how to interpret the different things of the tool. And finally, we will cover a summary of how we can use these tools to evaluate the learning process and to do things like relationship mining And finally, we will cover some conclusions and future work. Well, one of the big problems in learning analytics is that there is already a big amount of data that is available in all the systems. And this data is usually in the form of events, logs, and in most of the systems, technologically, this is already possible to have all of this data. This is something that is almost solved so far. There are also proposals for formats of data, like contextualized attention metadata from the group of Martin Wolpers. And about the retrieval of data, many systems already have this data available. But the big problem, one of the big issues of learning analytics is how can we transfer this low-level data, this raw data that is there, so that we can transfer this raw data into useful information that can be used by stakeholders. So a stakeholder maybe wants to know, okay, I want to know if this resource, this learning resource is good or not. I want to know if the students learn in an efficiency way. So this is high-level information, but at the first step, we don't have this higher-level information. We only have the raw-level data with the events, like the user with ID whatever accessed the forum resource in that time, and so on. So nowadays, for example, with the MOOC phenomenon, there are thousands of data, big amount of data in all of these platforms like edX, Udacity, Khan Academy, Coursera, edX. But not only in MOOCs, also in learning management systems like Moodle, Dotler, Dokeos, whatever. So one of the big questions is how can we transfer this data, this raw-level data, into useful information, and how can we present this data to the stakeholders that need to make the decisions so that they can interpret and understand in an easy way all of this information. So this graph in this slide is like the different steps that should be done in learning analytics. So first of all, we have the collection of data, the generation of these events, to collect, to monitor, to visualize this raw-level data. And this is the first step here. And the first question here is, what is the necessary data? As I told, many systems already provide almost all type of data, and everything, almost everything in a lot of systems is registered. So this first step in many cases is already solved, but there are also issues like what formats should we use, how should we store in the database, what is the best way to combine different data from different systems in an interoperable way, and so on. So there are needed research and research opportunities also here. The next step is the transformation of the data from this raw-level data that is here into higher-level information data. And these are some transformation modules of the data. And here, the questions are, what data should we obtain? What information do we need? And how can we obtain this information? Because how should we process this low-level data in order to obtain what we want here. In addition, we have also another step that is about things, most of them related to statistical analysis, like relationship mining, knowing the relationship between different informations, knowing about the causes, the detection of the causes of different themes in the learning process. Clustering, prediction of the future based on the data that is here. To predict the future is a very important thing. If we can predict the future in learning based on the data that we have in the past, this is really very useful. If we can predict, for example, the dropout in the future, we can take measures if we detect that this is going to happen, or if we detect that some resource, learning resource, is not adequate, or so on. And finally, in the last step here, we have visualizations for teachers, students, other stakeholders, recommendations for teachers and students so that they can act in the learning process. And another example is a report generator. In addition, there is a loop here in which, with this statistical analysis, researchers can refine the type of transformation that is done on the low-level data. Good. So the tool that we are going to present here, that is Alaska, we follow these steps that are in the previous slide that I've just commented, and we try to do to make progress on each one of them. Specifically, the tool that we are going to present has been applied in what is called in Spain zero courses. And zero courses are courses for freshman students that come from the high school and they register for first year degree in university. And one of the problems is that these students usually do not have the required background to pass, to be able to follow first course degrees, because they usually don't have the required background in topics like physics, chemistry, or mathematics. So in this context, in University Carlos III of Madrid, we enabled the Khan Academy platform, but also in combination with the Moodle platform, in order to help these freshman students that are entering the university for this first year, in order to learn physics, chemistry, and maths. And each of the courses had between 100 and 300 students. And we have already applied this approach with the introduction of the Khan Academy platform for the last 2 years, and this year is also expected now at the end of July and also during August and also in September to be enable again this Khan Academy platform in combination with Moodle for reinforcing these freshman students with skills that should be requirements for the first year's degree courses. I should also say that before this, in the University Carlos III of Madrid, we already had these zero courses, but they were just face-to-face. With the introduction of these platforms, we add this online component in addition to the face-to-face lessons in order to try to enhance learning. Okay, here there is a reference, a global reference in which we describe in the IEEE EduCon conference about this experience, this introduction of Khan Academy and Moodle platforms for these zero courses. Okay. Is it okay? Okay, I had some problem in the slides. Okay, so in this another research paper in the eMOOCs conference, we analyzed about the issues that we had when introducing this experience in zero courses. Like we had to create an extra authoring tool so that teachers can create their own exercises in the format of the Khan Academy, or the necessity of adapting the gamification features of the platform, and so on. And now I will give here some slides about how the Khan Academy platform looks like, and students have a set of videos like this that they can watch, they can write comments. In addition, okay, thank you, Jose. So in addition, there are some exercises like this in which the students should solve some statement, and if they need help, they can ask for hints. They can watch related videos and so on. Jose, can you go to the next slide? Thank you. So there are also gamification features in which students can earn their own budgets by doing certain things on the platform, like solving correctly different exercises. So this is a way to be motivated to win these budgets for different actions in the platform. Okay, so there was a learning analytics module in the Khan Academy, but we have extended this module, and the first thing that we done is to infer some information from the raw data that was in the Khan Academy platform. So I will show some examples in the next slides about the things that we have tried to infer, in which things should we look at in order to infer this higher level information. So we took into account, first of all, pedagogical theories that are published in the literature. Sometimes it's difficult to adapt a pedagogical theory to the data that is in a platform, and trying to apply this pedagogical theory in order to infer higher level information is not an easy thing, and you need to make decisions that are not so clear in the pedagogical theory, but you need to make an interpretation of that. Another thing that we use for doing this inference of higher level information is to use best practice that are published or ideas that we can have. Another thing is that in other systems there are already models that work well, and then one can reuse it but adapting to the platform. So this is another way to do that. And another thing to do that is that you need a refinement of the measures that the transformations that you are implementing. Because, for example, if you define something to infer some emotion like happiness in the system, if some student is happy or not when he's interacting, but you can make it based on some theory about happiness, and you interpret your logs according to your pedagogical theory, and you try to infer that. But if you have doubts of if this is working or not, and you see, for example, that this measure that you created is not correlated, for example, or cannot predict learning, maybe this metric is not useful. So sometimes you need to refine the metric, and you need to see, for example, if with the refinement, with the change of the metric, your prediction can improve. And if your prediction, for example, can improve, and you notice that in the loop that was in the graph, then you need to modify your metric that you define. Because another metric, even if you don't know if this is happiness or not, because you try to infer, for example, happiness, but maybe you don't know if this is a good inference or not, but you can change, and maybe you don't know if this means happiness or not, but you know that with this new metric you can predict something that you would like to predict in the future, like learning. Then you need to change, and you say, okay, I have this metric, you can name another name or whatever, but this can be more useful than the one that was before. Well, so now we have defined about 20 metrics in our learning analytics extension of the Khan Academy platform. And I'm going to show now three of them. Well, in addition to these 20 metrics, for each one of the 20, in many occasions, we don't only have one way to calculate one thing, but we have many ways. For example, for the efficiency, we don't have just one metric, but we have different metrics to calculate the efficiency of students. Sometimes we calculate the efficiency just taking into account the number of attempts that the student makes, or in other metrics, we take into account the time that the student spends. So other times a combination with different weights of different variables. So for the 20 metrics, the 20 higher level information parameters that we have defined, in many occasions we have different ways to calculate them. So it's like, okay, we can have more than 20 because some of them have many different ways to calculate. Here is an example, for example, of inference of information about hint abuse, hint avoidance, and reflective user. So here, tracking a student, and depending on if a student, for example, didn't answer correctly, we check if this student had watched the related video or had requests for the specific hint. And if the students didn't answer correctly, but didn't request the hint previously, then we have a counter for counting as a hint avoider or a video avoider. Or if the student is answering very quick the question, when he answers very quick, depending on the quick he is, he's also counting for the unreflective user parameter. We have this parameter from 0 to 1. So, for example, a student cannot reflect on their learning at all, and this is a 0, or can reflect a lot. This is a 1. This is another example. Well, the previous example was presented in the Learning Analytics conference in year 2013. This another example has recently been present in year 2014 in a workshop in Guatemala. And for example, this graph is for detecting frustration. So from the low-level data, we transfer this low-level data in order to know if a student is frustrated or not. So among the ideas for this detection is that the actions that the students do that are close to the specific moment where we try to detect frustration are taken into account more than the actions that took place some time ago. So it's like there are a weight depending on the seconds that the student did the action from this moment. Because if a student is frustrated but makes some actions that avoids the frustration, the more recent actions are taken more into account, because this is going to change the state of the student. And then we have different actions to know if a student is frustrated or not, like if the student is answering correctly the exercises, if she is asking for hints, and so on. So there are this processing of information of the different events in different instance of times with different weights depending on the instant of time and depending on if the action goes for students to be frustrated or not. And finally, students are modeled along the time with a parameter that is frustration that goes from 0 to 1. Jose, can you go to the next? Thank you. So this is the last example. Here we try to calculate the effectiveness on resources, on videos, and on exercises. And we defined an strategy that is the precise effectiveness strategy that tries to give a precise measure of the effectiveness when users are interacting on videos and on exercises. So the idea is that we don't not just measure if the student watched a video or not, or the percentage of video that the student watched, but we take into account that, for example, in a video, in a course, for example, if you see a lot of percentage of the video, you should have more than the percentage, that the linear percentage. Or, for example, in parametric exercises, when you answer one exercise correctly, this is going to count at 0.6. And if you answer 2, it's not the double of answering 1, because this exercise is strongly related to the last one. So it's like we should define strategies to take into account for the effectiveness in a more precise way, taking into account the relationship of your resources and how the semantics of your videos, your exercises are. Of course, this is just an example, but depending on your material, these graphs can change dramatically. Okay, so this is just 3 examples about all the metrics, just to let you know some types of processing of information that we are doing. And now Jose is going to continue with the presentation.
Okay, now I'm going to go a bit of more into the practical matters of Alaska. I will start a bit telling the architecture, and then we're going to show the practical way of. Can you turn off? Que si no hace eco, si no cojo el otro, Okay. Well, I think we're going to keep on going. Okay, well, our objective, as Pedro has said, with Alaska is to provide a new set of metrics which could support the learning process better for the stakeholders of the courses. One thing that is different from the Khan Academy in this design is that Alaska is prepared to support different courses in the same instance of Khan Academy. That means that we can have, for example, a physics course, a chemistry course in the same Khan Academy instance, and still have different metrics for each one of the courses, providing the instructors with different visualizations and privacy matters. The technologies that we have used in this development has been basically the same that Khan Academy already used, which is Google App Engine for the infrastructure of this platform, and its data store, that is for data persistence, the way that they use to store data in a database non-related. Under the programming language is Python, and for visualizations we're using Google Charts API. A bit more of this we can see in this reference that explains a lot of the technical details about Alaska, but I'm not going to be much going into detail into this. This is the architecture. I'm going to go fast because it's more useful to see visualizations. And students are the ones who are supposed to interact with the course, generating the data, which will be stored in the Khan Academy database. And they can access their individual visualizations for their own self-awareness, only their own. They cannot access of other people, and neither for the entire class. And the teachers who have developed the course can access the individual visualizations for all the students in the class, and also class visualizations will give an overview of how the class is progressing with all the indicators. All this is going to be stored in the Google App Engine data store. There's different models, the ones that were built by default in Khan Academy, and the ones that we have developed for Alaska. Probably the most important module is the data processing, and we'll go to that later. And the recommended system is part of the future work. We don't have already implemented it. So, okay, so probably the most important problem to solve in this work is to be able to provide a good experience to the final user. This is a real problem because some of these indicators that Pedro has been talking about need from 30 seconds to 1 minute to be processed. So this is not possible to let a final user expecting for 30 seconds their request, and it's not possible. So we have to process these indicators in regular intervals. So when a request is made, it has to be almost instantly to get the visualization and the results to be useful. So very fast, this is the design to make the vast amount of processing into smaller parts that can be managed by the system, and therefore can be accessed by the different users. First, the cron jobs are just some jobs we execute regularly. It's a HTTP request to a URL. So this will start the process in a regular interval. We'll generate one task that we can think of a small unit of work that can be managed by the system itself. Each one of these tasks will be in a queue. And this is transparent for the developer because it will be the system which will handle all the queue with all the tasks, and it will execute them as it is possible without collapsing the process. Each one of these tasks will execute a custom processing, a series of indicators that will be restored in our Alaska models, and whenever it's required, whenever there is a request, we will retrieve this information just to show it in an instant. One important to note is that this design is absolutely independent from Khan Academy, therefore there are no problem in installing this plugin. Okay, we're going to go now to see how a bit more of Alaska in action. First, I'm going to show some visualizations which has not been extracted directly from Alaska, and later some visualization from Alaska, and then a real demonstration with a computer. Okay, so more or less, as Pedro said, we have provided 21 different indicators, new indicators, which weren't present in Khan Academy by default. And we have divided them into 6 models to let the users, to not overwhelm users with too much information at the same time. But the design of the interface, our priority was to make it as simple as possible, so the final user does not need technical requirements to understand these visualizations. We have also used colors with a certain purpose, and also maintain the same standards in the entire application. We have provided class visualizations, which are mainly pie charts, and individual visualizations, which are mainly bar charts. And this is actually, this work of Alaska, which it tells these central ideas, is already accepted in the Journal of Computers in Human Behavior. So this first visualization is to try to infer persistence by using 2 indicators, like the number of videos started, which is the green dots, and the number of video finished, which are the blue dots. And the longest the line that is between these 2 dots, the longest is the line, logically, the more videos that they have abandoned. Therefore, we can see some students who have finished all the videos they have started, and other extreme users, like the number 13, that all the videos of the course has been started, however, none of them were finished. In this case, we can see the time in spending videos in the green bars, and the time spent in exercise in the blue bars. Each one of these is a user, as the last one, I didn't say it. Each one of them is a user. And we can see some examples, like see students who have different tendencies, like the 16, which have spent a lot more time in exercises than in videos. And the opposite case, like 17, we have spent a lot more time in exercises than videos. So we can check by these different tendencies of students in their learning process. This graph was directly extracted from Alaska. It shows a class visualization from one of the courses that Pedro has explained. We can see that for this case, the exercise correct progress has been lower than the video progress. And we're going to see this more in the demonstration. These are the type of visualizations that we use in Alaska for individual students. We have tried to always express the units in percentage, so it's easier just to look at the graphs and understand at the first sight what is the information that is being provided. In each individual visualization, we can see the first line, which is the line for that metric for that user. And the second line is the classroom mean, which means that we take into account all the students in the class, and we share it there. We calculate the mean and we put it there. So we can have a notion of this student is way ahead the class or behind the class. So in this graph, we can see, for example, that the student have access, this is the metric for different exercises have access almost all the exercise in the class. And also he has access almost all the videos in the class, but there's an important difference, such as the abandon rate of exercises is very high, almost the 60% or so. However, he has accessed all the videos that he has finished all the videos that he started. In this case, this is a graph about the module of correct solving habits, correct solving progress. And we can see that two students, student A and student B, have made a similar exercise correct progress, which is way ahead the class. So they have both made a good progress in exercises and also in videos. However, we can see an important difference, that is that student A, its efficiency in exercises and in videos is above the class. Yeah.
Can you explain the different indicators? What does it mean video correct to finish video? Or are the solving exercises efficiency?
Well, you mean what's
the meaning of this indicator?
Okay, the simple meaning progress is taking into account that the course has a series of exercises, is how much he has progressed in all these exercises, the same for videos. And efficiency matters. I can't tell you right now the specific formula, but in this case we take into account both time and number of attempts required to correct solve an exercise. And in video matters mostly if the student needs to watch more than one time videos. Okay. So this is the important difference here is that, as we've said, the progress is similar for both students, but we have a student A who has been more efficient in his learning than a student B who has been much less efficiency in both learnings. Okay, in this case we are trying to calculate how constant has been students during the learning period of time, but because this course was in a schedule, it wasn't open all the time. And we try to do that by calculating the mean of the course take an entire month. So we calculate the mean time spent in each day of the course and also the variance. And then we have in this first bar the mean time, which is for the student is around 12 minutes per day, which is multiplied by 13 to know how much time in total. By 30, sorry. And in this case, there is a similar amount of time. So we have both students have made a great effort, because they are very above the class, the mean time of the class. However, we can see an important difference, that is that the variance for this student is very low compared to the class, and in this case it's completely opposite. It's almost 4 times higher. Therefore, these two students has spent a similar time in this course. However, the second student has probably worked around only 5 days in the course, while the first one has been working a bit each day or something like that. Related to this, we would like to prepare also a measure that express the constancy only from 0 to 1, so it doesn't have to interpret like mean and variance. Okay, this is the last visualization example, and it's related to this distribution of time in different time schedules of the day. And the first graph is how the students have distributed their entire time in 3 intervals of time: morning, afternoon, and night. And well, we can see that this student has focused his learning in the morning and in the afternoon, and this one has distributed it more equitably, but it's not important. What is important is that in the second part we calculate the same efficiency that we have shown previously, but in each one of these intervals. And we have this user who has an efficiency which is very similar in the 3 time intervals. But in this case, we have this user has an efficiency which is very different from morning to afternoon or to night. This could be useful to send recommendations, so maybe this is not concentrated in the afternoon, or we should just recommend him to work in the morning because he works better. Okay, and now we're going to go to the live demonstration of Alaska. I'm going to show the interface and how to navigate between the different parts of it, to show how to analyze and make an overview of the class, and just to analyze some of the students that I have previously selected. And this is going to be published, it's already accepted, this is going to be published, a demonstration of this tool in the Excel conference in September. Okay. So, it's okay? Okay, this is the home tab of the application. This is just for the final users so they can read about the tool and learn how to use it. And it's present in these tables, each one of the modules that we have divided interface and all the indicators, giving an easy explanation of what kind of information provides each one of them. And the About tab is just for contact. The User tab is for individual visualizations, and the Class is for class visualizations. We're going to start here. So the total use of the platform module gives information about global amounts of use. Some things that we can see is, for example, that this data comes from a mathematics course from last August, and it has around 240 students, I think. So we can see things like, for example, the amount of exercise that has been abandoned is much higher than the amount of videos that has been abandoned. So this can provide the teacher to see if maybe exercises are too high, the difficulty of exercises are too high for the contents that are being explained in videos. Some of the indicators are to know if the students focus on videos or exercises, as the bar chart that I showed previously. And in this course, 40% of the students have more a video profile, and 28% are more exercise profile, and the others have an equitably profile. For example, we can also see that if the students have used optional activities, and as you can see, we have tried to use in this case always blue for indicators that are related to exercise, different tones of purple for videos. Related to the correct progress, we can see how well the students are doing in the course in terms of progress and efficiency. In this case, the exercise correct progress is different than the other case, and it's been very similar, the amount of progress in videos and in exercise, which is good because it should mean that it's well balanced. We can see also the time distribution, how students spend more time. We can see that most of the students has a morning profile, 34% of students, and an afternoon profile. Only 3 students, which is 1%, has been working more at night than the other schedule. But we should also take into account that most of these students were 18. So, and the efficiency, we can see that most of the efficiency in the time intervals is very similar, which it should be like this. But then we can see different examples like we saw before for individual students, which are more interesting. Okay, we can see about gamification, but we're not going to go into detail of all this. Other thing that was useful for the instructors was to implement a customized measure to know if the students have made enough effort or have fulfilled certain requirements to pass the course. And in this, here we can see, well, the name of the student is qualified, of course. We can see the ranking of the students that was available for the teachers to see how are they doing. Okay. Now we're going to go to some individual visualizations. I have prepared some examples of some students that I think are interesting, but we would watch all of them. So the first one is one student whose learning has been more focused on exercises than in videos. As we can see, he has accessed 100% of the exercises, and he has accessed 88% of 68% of the videos, and only 10% of the exercises that were accessed, which were all of them, has been abandoned. So he has made a good progress in the exercise because he didn't abandon much of them, he completed them. In the other case for videos, he accessed 68%, but he has abandoned all of them mostly. So he has just gone into the video, watch a bit and close it. Therefore, he has made a good progress in exercises and a low progress in videos. And in this case, we can see that this student has a poor efficiency in exercises, which could or not be related to the fact that he has been abandoning videos. The distribution of the time, he has more or less focused on the morning and in the afternoon. He has shown interest in gamification, just going a bit speed. And the next student has made a different progress from the last one. In this case, he has accessed, again, almost all the videos, but in this time, he has abandoned all of them. So he just tries to start a video, but he actually can get to finish and complete the exercise. This can be related, and this does not make much sense because he has accessed all the videos, 100% of the videos, and he didn't abandon any of them. So he has finished all the videos, and still he's really struggling while doing the exercises. So he's probably not paying enough attention to the videos, or not spending enough time doing the exercises. Some other interesting student. I'm presenting some extreme behaviors. In this case, this student has accessed only 10% of the exercises, and he accessed all the videos and finished most of them. As we can see in the progress, he has finished almost all the videos. And actually, we have a student that has accessed the platform, and he only watches the videos. He didn't even attempt the exercise because he didn't access them. So he's just logging in, watching his videos, logging out, and not even trying exercises, which is curious. But there are not only these extreme cases. There are more equitative cases like this one, which has made a similar progress in exercises and also in videos. I'm going to show now some metrics about the behaviors of some students. In this case, we have these behaviors were explained by Pedro before: hit avoidance, video avoidance, and we have more like recommendation listener because Khan Academy provides recommendations of what resources you should access next. We can monitor if the student has accessed this resource through that request, through our recommendation or not. And also, if the student usually learns how to solve an exercise, but then later he solved it. He tried to solve it and failed to do it. So we call this a forgetful user, and the others are the one that Pedro explained. So in this case, we have a student who has a very, very high hinge avoidance and video avoidance indicators, which are very above the class. So probably this student doesn't use the resources that are at his disposal, like hints and videos. And a direct recommendation could be to say him to use them. But there are not all bad students. There are also some correct students who has made a more correct progress, such as this one, who has accessed all the exercises in the course, and he has abandoned none of them. So he accomplished to acquire proficiency in all of them. He has accessed 80% of the videos, and again he has abandoned any of them. So he has made a good progress in both video and exercise with a very good efficiency. In addition, he has behaved in a constant way and has made an effort much above the class. And the behavior metric shows that this user is also following recommendations of the system. And all the negative indicators are very low and always under the mean of the class. So we are here before a student which has made an appropriate use of the platform, we can say. On the other hand, we can also find students who has made a non-appropriate use of the resources, like this one, who has been hint avoider, video avoider, unreflective, and hit abuser. So he's got all of them. Okay, so we are done here with Alaska, with the demonstration of Alaska. The next point is to tell you a bit more of what research we have conducted to evaluate the results. And this first reference is very related to the one that Pedro has been explained before about the effectiveness, but it's much wider. We also here provide an exact methodology to follow in order to measure effectiveness in different contexts and different types of educational activities and resources. In this case, we apply it to parametric exercises and videos, and we check the effectiveness of the 4 different courses that where we have used Khan Academy to compare them, and also to offer different statistical analysis and visualizations to go a bit further. And this is actually on major revision state in the Journal of Computers in Human Behavior. Another evaluation of results is related to the use of optional activities in virtual learning systems, virtual learning environments, sorry. In this case, Khan Academy, we apply this research on Khan Academy, and we took into account the 5 different optional activities that were not necessary to complete the course, like commenting on the videos, voting up, down on indifference in the videos. Also establishing goals, which is, for example, to say, okay, I'm gonna finish these 2 exercises and complete these 2 videos. And if you do that, you get an award, you get points, you get a medal, a badge. And the other 2 is profile personalizations, like changing the avatar image and changing the display of badges that you have earned, and you can put public in your personal profile so that students can see them. This research has been actually accepted for publishing in the ECTEL conference again in September. And in this research, since it has not been published, I cannot tell a lot of it and not much results, but we find that the use of these optional activities is very low if we compare it to the regular resources of the like videos and exercises in these experiences. And also we analyze which of these optional activities has been used less and more. Okay, this next paper, we found that we believe that these experiences were very successful because we make a comparison between the mean of the scores obtained by the students taking these 0 courses when using Khan Academy and before when they weren't doing it. When they weren't able to use it. We also make an analysis of the indicators of Alaska, and we obtain the opinion results from the surveys that we launched to the students. And we are participating in the Learning with MOOCs, a practitioner workshop in the MIT. Okay, much of the work has been also related to establish statistical analysis. I'm going to put here a couple of examples, but we are preparing a lot more of them. And in these examples, we found, well, this was actually one of the first of our works that Pedro also said that we published in the Learning Analytics and Knowledge Conference in 2013. And we found that the amount of, the total time is significantly correlated at 90% of level with the amount of videos completed, videos started, exercise access, and exercise with proficiency. Also, related to the behaviors that we have been talking about, we found some interesting correlations. The ones that are in bold are the ones that were statistically significant. For example, we found that video avoidance and hit avoidance are significantly correlated, which makes sense, because if a student tends not to use hints, he probably doesn't use either videos. He's not using the resources available in the course. We also found that the unreflective user profile is significantly correlated with hint abusing and video avoider. And some other correlations that were not significant make sense because it makes sense that the hint abuser is negatively correlated with hint avoidance, because if a student is abusing hints, it doesn't not make sense that he's also avoiding hints. It's kind of contrary. And this is the last reference, again, the optional activities. And in this work related to statistical analysis and correlations, we check for the correlations between the use of optional activities and learning metrics, and also the different behaviors that we have been providing here. And we also analyze by contingency tables the use of the different optional activities differently. And this means, for example, if there is an association between the use of a personal profile and the use of or writing a feedback, if a student tends to do one thing and the other. And we found actually some interesting results that will be published here. So now comes the conclusions, which are gonna go by Pedro. If some of you want to test Alaska later, you can do it by all means. Pedro, please.
Can we change, please, to today's microphone? Okay, so yeah, maybe, yeah, I think this is. Thank you. Okay, so Alaska is a tool that allows at this moment the visualization of different graphics, and these graphics are created, are based on some metrics that we use processing some information, so raw data, that we make different transformations in order to make this higher level information, so that teachers can use it, and also students, with the goal of enhancing the learning process. Alaska has been so far used in 2 editions of the Zero courses in our university, and it's going to be used in this 3rd edition now in August. And I think there are a lot of work ahead on this research. On one hand, there is always a need of refining these parameters, this information that is inferred from the raw level data. And these changes can be based on the pedagogy models, also on the relationship from the research studies, trying to make the parameters, the transformation in a new way that can predict better what we want, for example, learning gains, etc. And there is also a need to refine the visualization, to create new useful visualizations. It's worth to say also that there are some parameters that are presented that can be reused, and there are others that cannot be reused in other contexts. So, for example, the gamification habits, to know if a student is motivated by the badges or not. This parameter, in one context where the gamification history is different, maybe this parameter cannot be retrieved. Or even if it can be retrieved, the way to retrieve can be different. Or, for example, emotions. We have made other works in other, for the detection of emotion in other contexts. And the models are completely different, because the actions are completely different. For example, we try also to detect emotions like frustration, happiness, and so on, in environments, in programming environments, in which a student has to use the GCC compiler, the Valgrind debugger, they have to use different Linux commands. So the events are completely different. So the algorithms to detect these emotions are completely different. So not everything can be reused. So when one tries to make learning analytics in some context, in some platform, one should know what should I infer, and next how I'm going to do that. But there are other things that can be reused, for sure. For example, in the environment I told you about programming, there are also exercises, and we can measure the efficiency as here in the Khan Academy. But it depends. There are different things that can be reused, other things that cannot be reused, and even what can be reused sometimes need to be redefined, the way to calculate it. And finally, about some future work that we are doing in this line, we are making more work, and we are conducting some work now about clustering of students, prediction of students, detection of causes of different things, and we are using different statistical analysis about that. And in addition, as Jose commented, we, as future work, we also want to make a recommender for teachers and students, so that the recommender can say the best actions in order to improve learning. So, for example, with the data that we have, with the metrics that we have calculated, we can know, for example, if some variables, for example, are good predictors of learning gains. There are already some works, for example, that say about the correlation and the relationship between hint abuse, attempt abuse, and learning gains. So we want also to know if some of the parameters that we have can predict, for example, learning or some learning outcomes. And if once we have this, if we have something that can predict the future, we try to make recommendations to teachers and students to say, okay, in the future this can happen, please, you need to not avoid the hints, or you need to try to do more exercises or whatever. So we try to do these recommendations, but not only for students, also for teachers. And we are also working, right, we started some months ago on trying to implement some of these metrics, some of these visualizations in the EDX platform. The EDX platform, also University Carlos III of Madrid joined the consortium of EDX. I think with University Autónoma de Madrid were the two first universities in Spain that joined the EDX consortium. And we are also working now on trying to make research on learning analytics in the EDX platform. So there are some parameters that we have already done in Khan Academy that can be reused as they are, but there are others that need to be recalculated in a different way because it's a different context, and there are also new metrics that we can calculate. We are doing research on that, also on the types of visualizations, and also we want to do research on recommendation on the EDX platform. So thank you very much, and we will be happy to try to answer if there are any questions.
Any questions about the audience?
Yeah, I have some. So, yeah. Well, congratulations for your work. You're very productive. It's incredible. So, I think it's very interesting to have this kind of tools, and they can be very useful for helping teachers to know a little bit more about what's going on in the platform and so on, as you have said. So, yeah, it's interesting. I have many questions. I will try to be short. The first one regards the architecture of the system. You said it's independent from Khan Academy, so it can be used by other. Well, I understood. You said that there is no problem to use this plugin or whatever. So, can you explain that a little bit more?
Yeah, actually, as you've seen, this architecture is only dependent to the Khan Academy data format. So it doesn't require Khan Academy at all to work. It only depends the data. Actually, I have it running in the local machine without Khan Academy working at all. Only the tool. So if you wanna transform the data format from one platform to this data format, you could do that.
At least you need the data format. Have you been working on the data format? Is it a standardized form or whatever?
No, we use we use for the processing the one that is in Khan Academy as it is. We haven't modified it, and we have added our own models, but which very high level information. There is no low level data. It's just like hint avoidance, this value, or a table to control the access to Alaska. I mean, we don't have a data format, and we are actually not proposing any of that. Our work doesn't go to that way. Although it's also a very important field of research inside learning analytics, of course.
Yeah, because for example, if you're trying to reuse this with the EDX.
Yeah, you have to do it mostly all of it by over again.
Or again. So
in addition, EDX have a very low level data by tracking logs, but very low model. It's all the same, like events. This, here, and that. I mean, it's not
It's not at the
useful
action level,
information
or-
at all. You have to process it, all of it.
Okay, okay. Well, this was the first. Well, for you have these results, and you've done, you know, the ones you have been showing us about the different behaviors of the different students, and you were making interpretations. So, have you tried to confirm those interpretations?
Okay, I have actually not said, but in our research works we also always say that we can make reasonable hypotheses, but we cannot confirm most of the affirmation that we are doing. I mean, we can say that this student has progressed more or less, but we cannot confirm the causes. I can see that the student has progressed more in exercise, and I could theoretically think that if he hasn't watched the videos, it could be by that cause, but I cannot confirm that.
For example, I was thinking of, for example, accessing the actual students, interviewing them, looking at the concrete things they've been doing in detail, just to, you know, making more,
their information,
getting more information
yeah.
to, at least at the research level, to be able to understand them better, these behaviors. That could be...
Yeah, we would like also to take into account surveys to make these kind of things. For example, if they have, for example, to put an example, to know if a student is motivated by gamification events, we are developing now work. And for example, we could make them a survey to say, are you motivated by this? Are you motivated by this? Are you motivated by this? And then checking the indicators if they are okay. If you are inferring correctly what you are trying to infer.
And also, this was at the research level, but at the practical level, if I were a teacher, well, I am, but if I was using that, I would like sometimes to know what's behind the bars, like having a kind of 2 levels to access the information, like first you have this first view of the behavior of the students, and then you detect that somebody has done something very strange, whatever, and then you may want to click and look at the, you know, at his actual exercises. Why has he whatever, or so... Do you know of this kind of platforms? Are you thinking of this kind of work or not?
We haven't actually yet made a usability test made by the teachers, and this may be one of the things they request
afterwards. That was another question. Do the teachers understand the different, you know, meanings of the bars?
We don't know yet.
Okay,
we hope
that was
so.
Another one. Sorry, And the last one, these kind of things work quite well when you have not so difficult to process data, like I suppose you have multiple choice exercises, or...
Yeah, there are multiple choice, but mainly it's fill in the blanks exercises.
Okay, so what's the limit of your system in this case, in this sense? What kind of exercises you can process, and which kind of exercises you cannot process? I don't know if you know what I mean. Like.
So we made the algorithms for the type of exercises that we had. That these are the fill in the blank and multiple choice, but if there are other types of exercises, we should think about, for example, the effectiveness metric should be redefined, because it's not going to be the same. But for other metrics, it can be the same. So depending on the metric, we need to redefine. In addition, I would like to give something additional to the previous very good question also. And it's that also was very good answer by Jose, but I would like to make another example here. And it's true that in many occasions you give the teacher some information, but this information can be interpreted in very different ways. For example, as Jose said, you cannot know for sure the causes sometimes. For example, in the graph with the videos started and video finished, maybe one student start a lot and didn't finish anything. And you can say at first, okay, this is bad. Because students start but don't finish the materials. But wait a minute, maybe the student is doing okay. Because maybe the students watch 5 seconds and he said, okay, I already know that in the video, then I'm not going to watch that. And this is a correct behavior. So sometimes, so you have this information, but sometimes you can reach a conclusion that is not good. You can say, okay, this is a bad behavior, but maybe it's not. But maybe you need these interviews, this extra effort to know for sure. For example, if a teacher, there are also face-to-face lessons in these courses, next the teacher can ask, okay, did you know this or not? And then or with other parameters. So sometimes just with the visualization, you don't know the cause, and you need additional information to be sure of your decision.
Okay, yeah. So you were more or less agree. And the last one, so this was, I lied before because I said it was the last. This is a little bit more, provocative. So you identify issues that happen, there are some correlations, but you don't know the cause of them. And all of them are studied in kind of a particular context. It's the same kind of exercises, maybe some kind of students, whatever. And are you expecting to have some, to build predictors that are, able to be successful with this difficult field we have, which is education and everything that goes together. So how do you feel about that?
Yeah, we are working about the prediction. So far the work we have done is most about relationship mining, but not about the prediction. But we are working on that. And we don't know at this moment. We hope we can find some good predictors for learning.
But you don't know why. You predict, but you don't know why.
Okay. Well, if you can predict, for example, learning, and you know that there is a formula for predicting learning, and you know that some behavior is not good for learning, then you can try to change the behavior. I think this is one of the good things of learning analytics. If there is something that, if this behavior can be related to a better learning, because if we make some detection of causes, and we detect that one of the causes of learning is to behave in this specific way, and there are already studies in some of these parameters, for example, from the intelligent tutoring system community, about hint abuse, hint avoidance, and they found, or gaming the system, they found things that can work for learning, things that are not good for learning. So I think if we can detect the causes, you can intervene to say, okay, you need to change this and this behavior in this moment so that you can learn better. So I think this is one of the big things. Yeah,
there are people that have abandoned that, it's a big challenge.
Yes. Yeah, so far what we provide is these visualizations, and teachers can help make decisions. But sometimes you need also some extra information, as you said. But I think it's a big challenge, yeah, to try, because there are also many variables. Indeed, another thing, also connecting with your question, and I think other things that were talked in other before also, is that I think also Antonio said something about that, is that in every work, in each work, each one defines its own parameters, because the platform is different, the context is different, there is not like a standard. I think this will be also very useful. Indeed, the measures we have here for hint abuse or hint avoidance are not the same as in the intelligent tutoring systems, where some people discover that some things are related to learning. So are our parameters related to learning? I don't know, because maybe because we use some ideas from the models that already demonstrate that it can be related to learning, but we need to confirm it. But why cannot we reuse that? Well, because in other contexts, for example, in this intelligent learning system, there was a glossary that we don't have here, or different types of exercises. So we cannot reuse the same way. We have to adapt the measure. So yeah, I think that there is a work also in the Learning Analytics Conference. I don't remember if in year 2013 or 2014, where there is a review of a lot of many works that have proposed parameters. And there is a classification, I don't know, maybe like, I think if I remember well, like more than 100 parameters, different parameters. I don't know the author, but it's in the Learning Analytics Conference. We have reference in some of our papers. So, but I don't remember at this moment the name of the authors.
Dykov. The author is Dykov, the first author. Dykov.
So there is an analysis of all of the parameters that a lot of, and it's not all the authors, they select some of them. Of course, it's very difficult to, but I think it's a very good review that these authors made. But there are so many parameters, and each one proposes different ones. And I think one is that there is also a need of consensus between the community, or saying, okay, what is going to be common? But there is also some diversity that is impossible, because the contexts are so different that sometimes it's not possible to do that. But maybe efficiency or something. So I think there are like different levels. One level is to say, what are the names of what we want to measure? Another say is, how are we going to process? So, and I think it's very difficult, and a lot of variables, and each environment can make a different one. In addition, you also mentioned about the interoperability at what level. And we have, as Jose said, the database that is stored in one format, in EDX, and in another very different format in the Khan Academy. And if you go to Moodle, it's a new one. There are approaches that, like contextualized attention metadata, that I think they are very good approaches, that I think can be used to try to make a uniform format for low-level data. And this can be used, we have used in other works, but for the Khan Academy, for example, we have not done, because we want to make directly the visualizations and go quicker. But we haven't done this translation. But this translation can be good in order to interoperate different systems with different events and different databases, to try to make, so this low-level data, there are works like contextualized attention metadata by the group of Martin Wolpers. Contextualized attention metadata, where there is a common format for low-level events of how you can store the information for that. And it's, yeah, I think this is very good for many things, but one of the things for interoperability issues between different systems. I don't know if I answered the question, or because I talk about a lot of things.
Yeah, like a discussion. A discussion. Any more questions? No questions? Okay, thanks for coming. This was the last talk. Thank you, Pedro, and thank you, Jose, for your extensive speech and demo and the discussion. And this is all. Thank you for coming, and no more.